The entry for Infinite from the 1911 version of the Encyclopaedia Britannica, read for Noetic by Luke Johnson. This recording copyright 2018 Noetic Series, LLC. All rights reserved. Infinite, from Latin in, not finis, end or limit, cf. fendere, to cleave. A term applied in common usage to anything of vast size. Strictly, however, the epithet implies the absence of all limitation. As such, it is used specially in 1. Theology and metaphysics, 2. Mathematics. 1. Tracing the history of the world to the earliest date for which there is any kind of evidence, we are faced with the problem that for everything there is a prior something. The mind is unable to conceive an absolute beginning, ex nihilo nihil. Mundane distances become trivial when compared with the distance from the earth of the sun and still more of other heavenly bodies. Hence we infer infinite space. Similarly, by continual subdivision, we reach the idea of the infinitely small. For these inferences, there is indeed no actual physical evidence. Infinity is a mental concept. As such, the term has played an important part in the philosophical and theological speculation. In early Greek philosophy, the attempt to arrive at a physical explanation of existence led the Ionian thinkers to postulate various primal elements, e.g., water, fire, air, or simply the infinite. See Ionian school. Both Plato and Aristotle devoted much thought to the discussion as to which is most truly real, the finite objects of sense or the universal idea of each thing laid up in the mind of God. What is the nature of that unity which lies behind the multiplicity and difference of perceived objects? The same problem, variously expressed, has engaged the attention of philosophers throughout the ages. In Christian theology, God is conceived as infinite in power, knowledge, and goodness, uncreated and immortal. In some Oriental systems, the end of man is absorption into the infinite, his perfection the breaking down of his human limitations. The metaphysical and theological conception is open to the agnostic objection that the finite mind of man is by hypothesis unable to cognize or apprehend not only an infinite object, but even the very conception of infinity itself. From this standpoint, the infinite is regarded as merely a postulate, as it were an unknown quantity. The same difficulty may be expressed in another way if we regard the infinite as unconditioned. Cf. Sir William Hamilton's Philosophy of the Unconditioned and Herbert Spencer's Doctrine of the Infinite Unknowable. If it is argued that knowledge of a thing arises only from the recognition of its differences from other things, i.e., from its limitations, it follows that knowledge of the infinite is impossible, for the infinite is by hypothesis unrelated. With this conception of the infinite as absolutely unconditioned, should be compared what may be described roughly as lesser infinities, which can be philosophically conceived and mathematically demonstrated. Thus, a point which is by definition infinitely small is, as compared with a line, a unit. The line is infinite, made up of an infinite number of points, any pair of which have an infinite number of points between them. The line itself, again, in relation to the plane, is a unit, while the plane is infinite, i.e., made up of an infinite number of lines. Hence, the plane is described as doubly infinite in relation to the point, and a solid as trebly infinite. This is Spinoza's theory of infinitely infinite, the limiting notion of infinity being of a numerical, quantitative series, each term of which is a qualitative determination itself quantitatively little, e.g., a line which is quantitatively unlimited, i.e., in length, is qualitatively limited when regarded as an infinitely small unit of a plane. A similar relation exists in thought between the various grades of species and genera. The highest genus is the infinitely infinite, each subordinated genus being infinite in relation to the particulars which it denotes, and finite when regarded as a unit in a higher genus. 2. In mathematics, the term infinite denotes the result of increasing a variable without limit. Similarly, the term infinitesimal, meaning indefinitely small, denotes the result of diminishing the value of a variable without limit, with the reservation that it never becomes actually zero. The application of these conceptions distinguishes ancient from modern mathematics. Analytical investigations revealed the existence of series or sequences which had no limit to the number of terms, as for example the fraction 1 over in parentheses 1 minus x, which on division gives the series 1 plus x squared plus ellipse, 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 ellipse. The discussion of these so-called infinite sequences is given in the article Series and Function. The doctrine of geometrical continuity, QV, and the application of algebra to geometry, developed in the 16th and 17th centuries, mainly by Kepler and Descartes, led to the discovery of many properties which gave to the notion of infinity as a localized space conception a predominant importance. A line became continuous, returning into itself by way of infinity. Two parallel lines intersect in a point at infinity. All circles pass through two fixed points at infinity. The circular points, two spheres, intersect in a fixed circle at infinity. An asymptote became a tangent at infinity. The foci of a conic became the intersections of the tangents from the circular points at infinity. The center of a conic, the pole of the line at infinity, etc. In analytical geometry, the line at infinity plays an important part in trilinear coordinates. These subjects are treated in geometry. A notion related to that of infinitesimals is presented in the Greek method of exhaustion. The more perfect conception, however, only dates from the 17th century, when it led to the infinitesimal calculus. A curve came to be treated as a sequence of infinitesimal straight lines, a tangent as the extension of an infinitesimal chord, a surface or area as a sequence of infinitesimally narrow strips, and a solid as a collection of infinitesimally small cubes. See infinitesimal calculus.